Hello students, this is Mr. Dunaway. Welcome to 7-4 Division Properties of Exponents. The property we're looking at today is dividing powers with the same base as we move into division. And I would be happy with you today just taking notes in whatever method of your choice as we look at division. If you want to use my template, which I recommend, where you copy the question on the left and do the work in the middle, that'd be fine. If you want to do it on your paper as well, as long as you can understand it and apply it when asked. So let's jump right into things. You need to have everything down. Hit pause as I go if necessary for you. The first example is x to the fifth divided by x squared. Well, as we look at division, let's begin by expanding it so we can understand the rule, because that's really the trick to making math easier, is understanding why these things happen, and then you don't have to seem to memorize as much. What we have in the numerator here is we have x to the fifth, which means x multiplied 5 times by itself, and x squared means x multiplied twice. And then notice what happens right here. I have x over x, and we know that any number over itself is actually the number 1. So it's like 1 times, there's another one right there, x over x, 1 times 1. All right, and then, so those two, that divided is 1, that divided is 1, so that means I'm left with just this. 3 x's multiplied. That one canceled out there, and that one canceled out right there. So my answer to number 1 is simply x to the power of 3. And you might already see the shortcut rule, and we're going to get to that in a moment, but just for the sake of understanding, let's do the same thing to number 2. Where in the numerator I have x multiplied 6 times, so let's expand that out. And that's multiplied by 5 y's, or y times y 5 times. And then in the denominator I have x to the fourth. And then I have y to the power of 2, and that's times. I'm going to jump over here so it can be under the y's, so it's going to be easier for me to cross them off in the next part right here. And then this x over x crosses out there. That's a 1, that's a 1, that's a 1, that's a 1. And then this y over y is a 1, and this y over y is also a 1. So I have x times x here, and I have y times y times y here. So basically I'm left with x squared times y to the third over 1, which I don't need to write. So there's my answer to the second one, and again there's the answer to the first. So by now you probably noticed that if I simply took, if I go back to number 1, if I took that 5 and that 2, noticing they're the same base, and subtract them, 5 minus 2 gave me 3. And you can see it right here. You had 5, you took away 2. Same thing happened here with this x to the 6th and this x to the 4th. If we subtracted that, which is what we did, is we took away 4, 6 minus 4 gives me 2, and 5 minus 2 gives me 3, which leads us to the property for today, which is right here. The rule is when dividing powers with the same base, we subtract the exponents. And here is the algebra way of saying that. And I would like you to have all of this part in your notes, please. So hit pause if you need to. Get that down, take a look at it, and I'm going to move right along to the next part of the video just to keep the time of the video down. So hit pause if you need to. And now I'm going to look at the same property that we just talked about, which I rewrote here, and you should have just written that down in your notes, that you have a to the m over a to the n. You subtract m minus n. That's your new exponent. The one thing I did not mention on that previous slide is that a cannot be 0. And m and n have to be rational numbers for that to really work. So we wouldn't use things like pi to do that. And if we had that in there, we'd have to do something else, which if we run into that later, I'll show you. So let's apply the rule that we just learned. Let's do the shortcut now. Let's save us some time to make sure we understand what's going on here. Here I have a to the 4th, b to the 8th, c to the negative 2, a to the 9th, b squared, c to the negative 6. So if I apply my shortcut, which means I have to have the same base, if I do, I can subtract the exponent. So I'm going to have a to the 4 minus 9 times b to the 8 minus 2 times c, be careful with your negatives here, negative 2 minus negative 6. Alright, well let's work this out because we're not quite done. Well, first thing I want to do is I want to change this subtraction to addition because that's less likely to make a mistake. So if I have 4 plus negative 9, which is 4 minus 9, that's a to the negative 5. B to the 8 minus 2, I think I can just go ahead and do that as 6. I'm okay with that. For this C right here, I'm going to change this plus positive 6 right there. So you basically have negative 2 plus 6, which is 4. Well, I'm not quite done with this because there should be something going off in your head saying, wait, there's a problem with that negative sign. We are not to leave negative exponents in simplified answers. So what I'm going to do is keep the positive exponents, but since that a has a negative exponent and it's currently in the numerator, I have to take its reciprocal, move it to the denominator, and make it a. Now I can make it a positive exponent. So there's my answer, b to the 6th, c to the 4th, over a to the 5th. Okay, and go back and review that one if you need to, and then I'm going to roll down and do one more example here for this property. Number 4. Same thing is happening here. We just have a division happening between some variables with exponents. So I'm going to match up the exponents, or I'm going to match up the bases. So the x bases, I have 2/3 minus 1/2. Now let me point something I just realized I didn't mention. You always take the numerator, the power of the numerator, minus whatever the power in the denominator is. Okay, I would 2/3 minus 1/2. Doesn't matter if it's smaller or larger. We saw that on the last question. On this a up here, where I had that 4, I went 4 minus 9. Even though 4 is smaller than the 9, you have to take the numerator value minus the denominator value. So in this one, I'm going to take 2/3 minus 1/2 times y. Whoops. I'll just keep that. I'll just draw over it there. Okay, y to the negative 6 minus 2. All right, then we got a little bit of math to work out here. Well, let's quick review of fractions. We can't subtract those unless we have a common denominator. So I'll do that real quick. 2/3 is the same thing as 4/6. 1/2 is the same thing as 3/6. So we have to use that to get 1/6. Okay, so that's 2/3 minus 1/2 is equal to 1/6. So I have x to the 1/6. And then let's figure out what this is right here. All right, negative 6 minus 2. Well, again, I like to change things to that, to addition problem. That's a negative 8. So I have x to the 1/6 times y to the negative 8. And then we have to simplify that negative exponent right there. So my final answer would be, the numerator value would be x to the 1/6 over y to the positive 8, making the exponents positive. And there we have it for you. Okay, that's the first half. I have to do one more video to cover the second rule, and then we'll be all done and ready to get to work.